Okay, so we're going to continue looking at various geometry transformation using a variety of different parameters. Again, kind of sticking with the distance parameter that was done in the first video. Again, just because we're using this one doesn't mean this is the only type of parameter you can use. As we get further in the tutorial series, you'll see that there's a lot of other types of parameters that we can use to manipulate the geometry and objects in Rhino and Grasshopper. However, I think this is, again, just a good way to get you familiar in how these things can start to occur. We'll stick with what we did in the last video of using this to create a series of points and turning that into a 3D grid of points and using a series of random points to act as parameters for distance. So again, I'm just going to randomly place a couple of these points around. I'm going to set multiple points. Okay. And so again, we're going to use a combination of some of the other principles to create this next one of attractors. So we're going to, again, figure out the distance or the direction between the points and their designated kind of 3 random points. So we can look at, again, these points. With these will give us our direction as well as a length, which is pretty much equal to this distance value. However, we're going to use it in a couple ways to use these random 3 points as either an attractor or something that kind of pushes these points away. So you'll see, depending on just changing of one of these components, how it starts to make a difference. So we'll start off by thinking of these points as attractors. So the points that are closest are going to get kind of brought into that more so than as they get further, they don't get moved as much. So let's give this a shot. So again, we're going to use this to kind of determine the amplitude, so how much it's going to get attracted by. So we have that direction. Now we need an amplitude. So we can use our distance or length to determine how much it's going to get attracted. So again, if it's close, we want it to move a lot. If it's further away, we don't want it to move it a lot. So I'm going to go to my math and essentially invert these values by taking this length and plugging it into the b and dividing it. Let's use a slider that's going to have a range. So this becomes our amplitude. Now I'm going to actually move these points using this amplitude. So you'll see that, let's turn this one off. If I keep it at 0, it's essentially going to stay as is. But as I start to pay attention to those 3 points, so again, to slide this, these points start to kind of attract towards them, right? So this is how we start to create this interesting attractor point. If I want, I can bump this up a little bit more so they can really start to kind of section in. You'll notice that some of these start to kind of go beyond that. So these guys over here, it's because the amplitude value is higher than its distance, so they start to kind of continue that direction, but they go beyond that. But there's an easy way to correct that, and I did that on purpose to show you why we're going to do that. And so in order to prevent that from happening, we're going to go to our utilities in the math section and set a minimum value. So whatever the smallest value is, that's going to kind of get capped at that. So if it's going beyond that distance, then it'll essentially just stop there. It's a little confusing, but you'll see. So if I'd use the actual length versus what its kind of reinterpolated value is, and plug that into there, now you'll see that as I drag it, they won't start to veer off. They almost just kind of disappear into those points. And I'm sure if I kind of really ramped this up, they'll eventually just kind of all merge into those 3 points. Almost, just about. But that's how we can kind of start to create some attractor points with those 3 objects. So we can do the complete opposite as well and kind of make these be propelled away from those points too by just changing the direction of that vector. So essentially just changing this connection to reverse it. So I'm going to go to vector, reverse, plug that in. And now you'll see when I change the slider, they start to go further away. This min and max is kind of affecting that, so if I just unplug that, you'll see that they'll just keep moving and moving and moving into almost infinity. So just by changing this, we can alter whether it's going to move towards those points or move away, which is a pretty interesting way to kind of alter the overall geometry of this kind of grid and start to morph it a little. Similar to the last one, we'll even look at how you can just completely alter the shape of something. We'll stick with something two-dimensional, just for the ease of explaining or going over this part. Yeah, I'm going to use this curve as my reference curve. I'm going to add, again, 3 random points. Okay. I'm going to use those into here. So again, same thing we've been covering, but now I want to alter the shape of something. So I'm going to go to the curve, primitive, and like we used before, there's the polygon tool. And why we want to use this is because we can essentially determine, based off the distance, affect how many segments there are. So we can have it have up to a dozen or so segments, or we could have it as little as 3 for a triangle. Radius, let's also change that to be around let's do 1.5 or 0.75 maybe. So we don't have a whole lot going on between them. And turn this point off so we can see it a little bit better. And so again, based off the distance, we're going to determine how many segments there are. What's going to be an issue is if it's less than 3 or less than 2 even, that segment's not going to actually be a geometry. And that's why we start to get this orange color, because that can't be a geometry if it's less than, or a shape if it's got less than 3 segments. So similar to what we did before, we can actually create a cap to that. So if it goes beyond 2 or less than 3, we can say anything that's less than 3 is actually going to represent 3. So math utility, and again, return the greater of 2 numbers. So if that value becomes less than 3, we can say it'll just stay at 3. So that's how that max value versus using the minimum earlier. Now you can see now we don't have to worry about that orange. The small shape becomes a triangle, and then the rest, obviously the further it is, it almost starts to look closer to a circle. But again, these are ways where we can start to alter the actual shape itself, so they don't even have to stay as the same type of geometry. So let's again go into this last one. We'll actually stick with something more two-dimensional in terms of a grid, but have that create 3D geometry. So we'll go ahead and just copy this part. And again, I'm gonna set one curve. And I'm going to create, again, maybe just 2 points this time. Vector closest point. Again, these are the grid of points. We'll flatten that by right-clicking. And then I'll reference those 2 points. Okay. We're going to use this to actually create different heights for our objects. So again, the closer, the shorter it is, the further away, the taller it is. So we can do something similar to before, where we could use this to create a series of shapes that we covered before, the Voronoi. So again, I'm just going to go ahead and flatten that from there actually and drag that into there. Here's our bounding box so that it doesn't go too far away. And let's actually change the radius. Oops, we probably want something a little bit higher than that, so let's try 3. And get that. I guess since it's not randomized, it's a little bit hard to say, but regardless, we've got some geometry here now. They slightly kind of leave some interesting tiling there. If this was kind of just randomized, it'd look a little bit better, so let's actually just, for the sake of this, create some random surface, some random points. So vector, grid, populate geometry. That will create these more kind of unique shapes. Again, we can even have some kind of empty space in some of those areas where other areas are kind of tight. Let's actually reduce the number because this can really start to lag. And we can just bump up the radius a little bit more. Now let's just stick with something like that. Okay. So again, I'm going to use this random point in relationship to here to give me my distances. And again, these distances will correspond to the actual height that these get extruded. So I'm going to go to Surface, Freeform, and just do a simple extrude. So it's asking for a profile curve, that's these guys. And then the direction. So I just want them to go in the Z direction. So this will just create a default of 1, I believe. But we can use this to actually create all sorts of unique heights in relation to that. We can go ahead and even just cap these so we don't have them as hollow. And now we start to see this kind of interesting geometry extrusions from this process. And again, these are based off of the height. So if I take that point and move it around, these things will start to adjust based off of that. So that's going to be it for the different type of transformations using this data. Again, it's going to continue to build, but this again gives you a lot more options to see what kind of manipulation you can do to geometry using a range of different parameters.